Hey everyone, welcome back to the lab. In this video, we're going to be talking about the HAMY stack, a simple, scalable tech stack for building modern web apps fast and cheap. So I build a lot of projects, and over the years, I've iterated on my technology choices to try and make it easier for me to build better projects for less cost. Because, the best way to get a better ROI is to just lower the amount of investment. And so in this post, I'll share my latest iteration of the best tech stack for building modern web apps fast and cheap that I found, the HAMY stack. Okay, so what is the HAMY stack? So the HAM in HAMY stack stands for Hypermedia on a Modulith. So Hypermedia here, this is just front end that is Hypermedia based because, basically any software that is useful will have a front end of some sort. Currently, my choice for this is HTML with HTMX and Alpine, which you can read a bit more about here. And then this Hypermedia is going to be on a Modulith. And so the backend is going to be a Modulith, which is built with whatever you want. So I currently use F# Giraffe with a Postgres DB, which you can learn more about here. But in general, I'm not too particular about how you build this Modulith, just that it's a Modulith. And we'll go into more in a second. And so this stack may seem like overly simplistic and generic. After all, Hypermedia can be built with many different tools, and a Modulith is simply an architectural pattern and thus can be built with basically any programming language. However, I think it's useful for realizing that good software, and really systems in general, can generally be built with any technology. It's avoiding the common pitfalls that counts. Because the pitfalls are generally what is going to be the blocker in accomplishing whatever it is you want with this software or with this system. And so this stack does that. It is specific enough to avoid common pitfalls while general enough so you can make your own choices for fulfilling it. So just like any problem actually has many different solutions, here we just want to kind of guide you towards solutions that avoid the most common pitfalls. But there are still many correct solutions, many viable solutions within there, and that's where you should direct your attention and your kind of decision power to figuring out for yourself in your own scenario. Now, I want to point out that this stack is heavily inspired by HTMX's HAL stack, which stands for Hypermedia on whatever you like. One of the big benefits of using HTMX and HTML Hypermedia in general is that you can basically build the rest of the stack with whatever you want, which is good, and that's correct, and I like that approach. But I did feel that it was a bit too generalized because it's still leading to a lot of common pitfalls with a lot of common architectural choices that people make. And so the HAMY stack tries to fill in some guidance gaps here by being a little bit more specific than the HAL stack. And so in the rest of this post, I'm going to be diving a bit more into the philosophy behind each layer, to try and give some background and some logical explanations for why I believe this is a good stack for most cases, and also why I've chosen to use this at least in the near future. Okay, so let's start off with Hypermedia. So my belief is that the web is here to stay. It's the best way that we've created to connect all of humanity and the best build once, run anywhere implementation to reach production and to stand the test of time. Obviously, we create these kinds of things all the time, but most of them fail, and the ones that even live long enough don't really get adoption, and they kind of suck. But the web, we've had the web for a while, and it's pretty good. It runs the internet. So the web is here to stay. And if you think about it, Hypermedia is actually the language of the web. And remember, HTML is a hypermedia. And if we think about it further, like everything on the web can be simplified down to simply rendering and updating HTML. Like even your favorite spas, so React, Vue, Svelte, Next.js, SvelteKit, Nuxt.js, I don't know, Solid, Remix, Astro, whatever that thing is that you're using, that's some fancy spa, if we actually think about what it's doing to enable the user experience, all it's doing is abstracting the hypermedia manipulation away from you, which isn't necessarily a bad thing. Obviously, abstraction can be helpful. It can simplify things. But at the end of the day, what it's enabling you to do is do this hypermedia manipulation because at the end of the day, the user's in a browser and it's hypermedia that they're seeing. And so I have a few theories about the future of the web, which kind of underlies this push towards hypermedia. My first theory is that we will be more connected and not less. There's going to be better internet for more people. Our internet's going to get faster. It's going to be able to reach more places. It's going to be more and more a given that we're going to have good internet. The next is that we're going to have better tools to build once, run anywhere. So the web, in my opinion, has already won, right? Like it's the most penetrated form of connecting people, and it's so valuable to, and really is the backbone of like basically everything we do in the modern world. And so it's possible that they might reinvent Hypermedia or something, but even today, really Hypermedia underlies everything we do on the web. And so as the web gets more powerful, more useful, more people are on it, more people are relying on it, I think it's going to lean into this Hypermedia or something like it, so that we can do a unified rendering across all of these use cases. Now, the next one is really focused on common reasons why people choose not to do Hypermedia, and that's because they want to make like a specialized thing for like a specific device, like an Android device or an Apple device or whatever, because they think that's like their edge or whatever. But my theory is that basically closed ecosystems that force you to use specialized vendor-specific APIs, a la iOS and Android, will be subverted. And so, when people choose not to build a web app and instead they choose to make a native app, yes, you get some benefits there. And I think you can win there short term, but long term, I think they're going to not be the winners. And the reason is we're going to have better tooling to build web things, so the gap will close on what's possible with these. These models are going to die due to competition. iOS is extremely closed. Android is a little bit more open, but both are relatively closed with these kinds of like weird specialized APIs. And I think the open model will win in the same way that the web really is still more ubiquitous than these. And the last reason is because even if they are valuable, they're going to be more trouble than they're worth, and that the incentives or the cost of getting on these specialized things instead of using Hypermedia will just be too high in terms of complexity, in terms of dev cost, in terms of like let's think about Apple and Google's monopoly on the 30% charges they're doing, and kind of the recent pushback we've seen of like, why would I do that when I just have a perfectly good service over here that someone can use on the web and I don't pay them 30%? All of which is leading me to believe that, the web is here to stay, and it's only going to get more powerful, more accessible, and thus more useful to, the world and people building for it. And it's going to get easier to build on in the future because more people are building, they're building tools to make it easier, all of these things. And so Hypermedia is my choice for building front ends because it's a simple scalable system that gives you a ton of benefit for very small cost, leveraging these theories for the future. And the main reasons are because it allows you to build once and run anywhere. It's extremely flexible with a huge ecosystem to leverage. Everything in JavaScript, and now probably even more stuff outside of JavaScript with the entry of WASM, is available to you. And I think in the future, this will only become more and more true. And it allows you to access the entire internet. So the entire internet can access you, and thus as a builder, you can access the entire market of the world, essentially, and definitely more than any, one operating system could net you. Okay, and so that's my rant for why Hypermedia is good, based on the future, direction of the world. And with that said, I'm not too picky on how you build this Hypermedia. I think there's a lot of tools. I think the tools will change over time. I think the main thing is that you're using Hypermedia, the language of the web. And so if you want to use a SPA, with React, Vue, Svelte, Next.js, whatever it is, sure, go use it. If you want to go low.js with things like HTMX and Alpine, great, that's great too. If you want to use the coolest, WASM wrapper with Blazor or whatever Rust has, or, I'm sure Go's going to come out with one, awesome. Do that too. Like, it really doesn't matter to me what you're using. I think Hypermedia is the philosophy. That's the choice. The implementation is up to you. Because any of these are going to allow you to target, the greatest interface humanity has ever created, which is, now personally, I've grown to like HTMX and Alpine for building modern web apps. I think it's very simple with minimal overhead, and this allows you to build modern apps faster and cheaper than a lot of these other alternatives that I've used. Which is kind of the whole goal. And then in previous lives, I've used React, I've used Next.js, I've used Vue, I've used Svelte and SvelteKit, I've used static site generators, like a lot of different things. I wouldn't consider myself a front-end expert. I don't really love it. But HTMX and Alpine has given me the simplicity to build these things that I want to build without a lot of the overhead, which has been really enjoyable. Another thing that I really like about this, especially in this stack, is that it's backend agnostic, which is giving me more flexibility for the next choice, which is the Modulith, which I think is really the differentiator between HAL, because it's more prescriptive on how you build this thing to try and avoid some of those pitfalls. Okay, and if you want to learn more about HTMX and Alpine, I have this comparison here on which you should use for your web app because this is a common question I get on my videos and that I see around Twitter. So if you're curious at all, this should answer some of those questions. Okie dokie. So we've already talked about Hypermedia, and if you're in HTMX land, you probably already sold on Hypermedia. But that's why I think Hypermedia is really good for the front end. Now let's talk about on a Modulith. And this is really where we are differentiating ourselves from HAL Stack because we're being more prescriptive about what you're using to build and serve this Hypermedia. So I've talked about this a lot on this channel, how I love monoliths. And so we're going to recap a little bit of that here. But in particular, I'm being a little bit more specific about the type of monoliths I'll accept, again, to kind of avoid some of those common pitfalls that I see so many people, enterprises, organizations, businesses, classes, etc. falling into. And that specific thing is a modulith. And so what is a modulith? So a modulith is a modular monolith. So, all moduliths are monoliths, but not all monoliths are moduliths. So we want to make sure we're building a modulith. And the reason I like this is that moduliths scale, and they scale often way more than the overpriced, underpowered, and overly complex alternatives that people often like to pitch, like microservices, or even worse, serverless functions, which are really just nanoservices. So it's microservices with more overhead. And thus, I believe moduliths are a great way to build modern apps and better than most of these alternatives that are pitched as good ways of building. And so I'm going to go on a little rant here because I strongly believe this, and I really believe a lot of people have this wrong. And so I really want to explain why moduliths are good, even though, I've got a even more in-depth post here. So here's the basics. The first one is scalability. Okay, so in terms of performance, a modulith can outperform essentially any distributed workload. So we're talking microservices, nanoservices, whatever you're using, in terms of outcome per unit of work, simply because it doesn't rely on intermediate network read IO, which we know is slow, calls. And so you always see people saying microservices, nanoservices, they're so scalable. And yes, they can scale very high. But if you actually look at ROI, we're focused on ROI here, outcome per unit of work is necessarily going to be cheaper and more performant on moduliths. This does have an assumption that the workload you're using can fit on a single modulith instance. However, compute is fast and cheap enough today that if you are not FANG, then your workload almost certainly can fit on a single modulith. And so yes, there are edge cases, but you're probably not in an edge case. Okay, next one is simplicity. So I think people think distributed software makes things simpler. Often one of the big things I see people pushing for microservices because they're like, oh, then our code can be more separated. Oh, our team can move faster. Yeah, blah, blah, blah. That's what everyone says. The thing is, if we think about it, it cannot get simpler than a single code base running on a single instance, okay? Yes, your code might live in its own repo. What are you going to do about versioning? What if you change dependencies? How are you going to do deployments? Like, there's so many things that come with distributed software that make it so much more complex. Like, it literally cannot get simpler than a single code base on a single instance. Okay, and I think when people talk about these things, they're thinking that the bottleneck in the system is performance. But basically the bottleneck in most systems is not performance. It's change velocity. Now, this is not true for some things like, video games, real-time trading, Fast F# builds his little simulations. Like in those cases, the edge might be the nanoseconds that you're saving. But if you're building an enterprise software or like a consumer-based software, you're not battling the laws of physics. You're battling cruft and bad code and bugs, changing worlds and leveraging those market opportunities. And so the bottleneck in your system is very likely not performance. It's going to be change velocity. How quickly can you change your system safely so that you can capitalize on whatever new change happened in the world? And so simplicity is likely what you actually want to optimize for. And so if you still disagree with me, you're still on the team of, oh, but microservices lets my team move faster, then I want you to just think about this, do a little mental exercise here. Think about what your distributed software's CI pipeline looks like. How does it deploy? What orchestration are you using? Also, how are you doing migrations? What configurations are you using? How do you create your network mesh? What does your control plane look like for all of these services and whatever else it's relying on? Okay, if I were to destroy it somehow, let's say AWS has an outage, the configs are gone, you gotta go, all you have is your code base. Could you get it running again? And my guess is if you're running on a monolith, the answer is yes. It might take a day, but you could get it. My guess is with a distributed system, unless you are all infrastructure as code, and even then, let's be real, even the things that run infrastructure as code have their own configs, the answer is no or extremely hard. I might be wrong, but that's my theory. Just think about it and let me know what your answer is. Okay, the next one is flexibility. So in my mind, the simpler the system is, the easier it is to change safely. And once we built a system that can reliably run workloads on autopilot, that's like, what software is good at. It runs on autopilot. We can scale it up and stuff. The next biggest advantage of software is to change it to leverage new insights about the world. Because if, we could only build it and it was leverageable, but we can't change it to meet, changes in the world, then it's actually going to be obsolete within, a week or a month, and we'd have to build the whole thing again. And so in my mind, Moduliths are often just much more flexible than their distributed counterparts for the simple reason that they're simpler and more scalable. And I think it's interesting here because a lot of people say that they like serverless functions. They say that they like microservices because it gives more flexibility to the team. And that might be true, but teams don't really work in isolation. They work within the context of a company. They work within context of a market. And so the only way that this is actually true, that making these changes is faster and safer in a distributed thing, is if built the Modulith poorly. And in most cases, the Modulith is fine. If it's a vertical slice architecture, you do that, you're going to be good for a very long time. If you disagree, fight me in the comments. I'm happy to have this discussion for quite a while. Okay, so all that said, I'm a fan of Moduliths because they're simple scalable systems for building software for most workloads. Yes, they're not going to be the perfect system for everything, but I believe they outperform most systems for very little cost, and thus overall they went out. Simple scalable system. And so that's my rant on Moduliths. Now, in general, I like building with a single Modulith where possible. Previously, I did a dual Modulith with front end, back end. That's okay. I've seen that work, but in general, if you can do single Modulith, way better. I think multiple Moduliths are okay when necessary, but usually only when separating disparate, specialized, and intensive workloads. So this is going to be things that if you tried to do it on a single Modulith would be very hard. And this is almost always only things that are extremely compute intensive or that would somehow disrupt other things. So when I think about this, it's like you're running a dangerous workload because you need to run dynamic code. You are doing something super compute intensive, like let's say video encoding or something like that. It's going to take up all your compute, or it's going to need specialized GPUs or like whatever it is. And so if you run it on your business logic, it will slow everything down. It'll be a bottleneck. In those cases, I can see the case for separating it out into its own Modulith that kind of, handles that whole service. But I think this rarely happens unless that thing is your edge. And is necessary, and really only necessary when you've hit hyperscale to where it's actually bogging down your compute. And even then, in most cases, is an anti-pattern. So only do it if it's the bottleneck. If it's just a nice to have, not worth it. And so my current tools of choice for building Moduliths are basically for the backend, F# and Giraffe, using Giraffe.ViewEngine for HTML generation. This is how we're connecting, the Modulith to actually serve the Hypermedia. And for hosting, I like to use serverless containers. And so this gives me all the benefits of a single server Modulith, including the performance and stuff, but I don't have to deal with the overhead of maintaining a server. And you can do this with things like Google Cloud Run or DigitalOcean App Platform. And I feel like this is one of the big reasons why people choose serverless functions currently, as opposed to serverless containers or microservices or something, because they're scared of the server overhead of maintenance and stuff. And I understand that. I think people running their own servers fraught with edge cases and things that you're maybe not good at, security concerns, etc. But I think serverless containers really is the simple scalable system, the balance of getting all the benefits of your Modulith without the overhead, and just outperforms microservices and serverless functions every time. That said, I'm not really married to these specific technology choices, neither for the Hypermedia or the Modulith. They're just simply the best tools that I've found for the job, and that's what I'm using today. All right, so overall, I've been very happy and productive with the HAM stack. It's made building full stack apps joyful again, and really shames these overcomplicated, over-engineered, and underperforming systems I see so often in enterprise. Now, I'll continue iterating on the specific technologies that I implement the HAM stack with in the future. I think the core value system, though, is here to stay, as long as the web functions reasonably similarly to how it does today. And if I had to guess, I would guess that the web will continue to work how it does today for a very long time. But because that's how we've been building for, 20 years now, and because we haven't really found a better paradigm that I've seen so far. And so I think building on the HAM stack, at least with this core philosophy, will have quite a bit of longevity. Now, hopefully we can get some enterprises to take note of this stuff and build some simple scalable systems. I personally believe it's better for the business that's implementing these things. because it's, cheaper and more scalable and allows you to change things faster. Plus, it's also way better for, us engineers because it's more fun, gets out of the way, gets us doing the things we actually like, which is building features and stuff, and not the dumb things we don't like, which is like searching for code and trying to figure out why things are wrong. So maybe one of these days we can get these enterprises on board. Now, if you want to get started with the ham stack, you can check out Cloudseed, which is the F# project boilerplate that I've built. It's the latest version of all these choices that I've made, and it's basically how I start all of my projects because it allows me to get set up with a full stack ham stack implementation in about 10 minutes. So you can get that here. You can learn more about how it works and how to get started with it here. And if you like this post, you might also like why I think monoliths win and software monoliths for scale, why I think hypermedias are better than SPAs in this post, and how I'm thinking about building modern apps with HTMX using F# and simple interactive islands with F# and HTMX. That's it for this post. Thanks for watching, and I'll see you in the next one.